Hi students, I am Praveen Sebastian Paul. In this lecture we are discussing the T flip-flop. Actually in the previous set of lectures we had discussed the JK flip-flop, and when we are analyzing this JK flip-flop, if the JK flip-flop is having a clock of 0, then it will preserve the previous output, that is we are dealing with a memory condition. In the case of clock 1 and j is equal to 0, k is equal to 0, then also we can see the memory condition. If the clock is 1, j is 0 and k is 1, then the output will be 0. If clock is 1 and j1, k0 results in an output of 1. And in the case of clock 1, j1, k1, we are getting an output of qn complement. And also here we can see a race around condition, and this race around condition can be overcome with the help of a master-slave flip-flop. So my dear students, the T flip-flop is a subsidiary or a subset of this JK flip-flop when we are considering the conditions of 0, 0 as well as 1, 1 for the j and k. This is implemented with the help of a T flip-flop. So my dear students, similarly in the case of an SR flip-flop, we had introduced the D flip-flop with the S value 0 and R value 1, and also for S value 1 and R value 0. For those subsets we had introduced the D flip-flop, but in the case of T flip-flop, if all the values of inputs are similar, then we can tell that can be implemented with the help of a T flip-flop. So this is the symbolic diagram for JK flip-flop. So if we are merging both the inputs, then we can consider it as a T flip-flop. In the case of a T flip-flop, if we are giving an input of 0, then both the j and k values will be 0. And if we are giving an input of 1, both of the values will be 1, and this type of flip-flop is known as a T flip-flop. The circuit diagram of T flip-flop is as shown in this figure. Here we can see that in the first set of NAND gates, both the inputs are same for the T flip-flop. And now we are moving towards the working of this T flip-flop. So if we are considering the truth table of T flip-flop, let us consider our first case with the clock is equal to 0 and T value as a don't care condition. This is similar to the JK flip-flop with the clock is equal to 0 and J and K values as don't care condition. Here if we are analyzing the JK flip-flop, the output of this particular condition is Qn, that is a memory condition. Thus, in the T flip-flop also, the clock with 0 and T of either 0 or 1 will result in a memory condition, that is we are preserving the previous data. If we are considering the clock as 1 and T value as 0, this is similar to the JK flip-flops. Clock 1, J0, K0 condition, there the output value is memory or Qn. Thus here also we can see, or we can tell that the output will be Qn, that is the memory condition. And finally, if we are moving towards the third case, that is clock is 1 and T value is 1. This is similar to the JK's truth table, clock 1, J1, K1 condition. There the output value is Qn complement. Thus the output of clock 1, T1 will result in an output of Qn complement. So my dear students, this is the T flip-flops circuit diagram, symbolic diagram, as well as the truth table. So as we mentioned, this T flip-flop is a subset or a subsidiary of the JK flip-flop with both of the inputs are similar in case. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, write notes on the T flip-flop. So my dear students, in the upcoming lecture we will discuss the characteristic table as well as the excitation table for this T flip-flop. So dear students, see you soon. Until then, goodbye, thank you, and all the best.